Ever wonder what makes the latest video games look so incredibly real? Like, so real, you could almost step right into them? A huge part of that magic is a technology called ray tracing. But what is it, and how does it transform your gaming experience from just playing a game to living in a virtual world? Let's dive in. Imagine you're standing in a sunlit room. Light pours through the window, bouncing off the floor, reflecting off a shiny metal vase, and casting soft shadows under a chair. That's how light works in the real world. It's a complex dance of rays bouncing everywhere. For decades, video games had to fake this. They used clever tricks and pre-baked lighting to create an illusion of realism. It worked pretty well, but it wasn't perfect. You'd often see blocky shadows, flat-looking reflections, or light that just didn't behave naturally. Then came ray tracing. Instead of faking it, ray tracing simulates the actual path of light. For every pixel on your screen, the game engine traces a ray of light backward from your virtual eye to see what it hits. If it hits a mirror, it calculates the reflection. If it hits a semi-transparent window, it figures out what's behind it and how the light should filter through. It tracks how light bounces from one surface to another, creating what's called global illumination. This means a red wall will cast a subtle red glow on a white floor next to it, just like in real life. The result? Mind-blowing realism. The first time I saw ray tracing in action, it completely changed my perspective. Take a game like Cyberpunk 2077. Walking through the rain-soaked streets of Night City with ray tracing enabled is a different experience. The neon signs don't just glow, they reflect realistically in every puddle on the asphalt. The chrome on your cyberware gleams with accurate reflections of the world around you. The shadows are no longer hard, static blobs. They're soft and dynamic, stretching and shifting realistically as you move. It makes the world feel solid and alive. Or look at Minecraft with RTX. A game famous for its blocky, simple graphics becomes a visual masterpiece. Sunlight streams through cave openings, illuminating dust particles in the air. Water becomes crystal clear, with perfect reflections of the clouds and blocks above. Gold blocks don't just look yellow, they have a metallic sheen that reflects your character's torchlight as you walk by. It's the same game, but it feels completely new and immersive. This level of detail comes at a cost, though. Simulating billions of light rays in real time is an immense computational challenge. This is why real-time ray tracing requires seriously powerful hardware, specifically GPUs with dedicated cores designed for these calculations, like NVIDIA's RT cores or AMD's Ray accelerators. Without this specialized hardware, trying to run ray tracing would turn your game into a slideshow. Even with powerful GPUs, developers have to be smart. They use optimized algorithms and even AI, like NVIDIA's DLSS, which uses machine learning to upscale the image from a lower resolution. This clever tech allows the GPU to focus its power on the heavy lifting of ray tracing, while the AI handles the final image quality, giving you a smooth frame rate without sacrificing those beautiful, realistic visuals. It's a perfect partnership of hardware and software pushing the boundaries of what's possible. So, is ray tracing just a gimmick? Absolutely not. It's a fundamental shift in how game worlds are rendered. It's the difference between looking at a picture and looking through a window. Games like Control use it to create eerie, realistic reflections in its sterile office environments, while Metro Exodus uses it to craft incredibly atmospheric, naturally lit post-apocalyptic landscapes. The subtle play of light and shadow adds a layer of depth and immersion that old techniques just can't match. As technology continues to improve, ray tracing will become even more common and more advanced. We're heading towards a future where every game has perfectly simulated, photorealistic lighting as a standard. It's an exciting time to be a gamer, watching as the line between the virtual and the real gets blurrier with every new release. Ray tracing isn't just a feature, it's the future of gaming graphics. Thanks for watching. If you found this deep dive into ray tracing interesting, hit that like button and subscribe for more content on the tech that powers our favorite games. Let me know in the comments which game you think has the best ray tracing implementation. See you next time.